So for these problems, we're going to introduce a method called U-Substitution. U-Substitution is an excellent way of taking a problem that looks quite complicated and reformatting it into something that we're familiar with. For instance, this problem looks like a basic quadratic equation that we've typically dealt with in the form of ax squared plus bx plus c. But it's these parentheses here that make things look a little bit more complicated, when it's really not. If we could just rewrite it in a format we're familiar with, we will see the basic overall problem that needs to be solved. So with U-substitution, we're going to look at what's in these parentheses and say let U equal that value, x minus 2. When we do that, we'll rewrite this entire equation with the variable u now. So the quantity of x minus 2 squared will become u squared minus 5 times the quantity of x minus 2 is now minus 5u plus 6 equals 0. At this point, we can solve with the quadratic formula or with factoring, since this is a quadratic equation. I'll go ahead and use factoring here, since this factors very nicely into u minus 3 times u minus 2. Since negative 3 times negative 2 is positive 6, and negative 3 plus negative 2 is negative 5. And now we can set each of these factors equal to 0 and solve. U minus 3 equals 0, u minus 2 equals 0. Adding 3 to each side in this equation gives us u equals 3, and adding 2 to each side in this equation gives us u equals positive 2. And normally at this point you'd be done. But remember, u is not the variable that we started with in this problem. We started with x. U was just how we rewrote the problem to make it feel easier to work with. So at this point, we will plug u's value back in. U is equal to x minus 2. So since u equals 3, that means x minus 2 equals 3. And since u equals 2, that means x minus 2 equals 2. And now we can finally solve for x in each case. We'll add 2 to each side of the equation here, and add 2 to each side of the equation here to get x equals 5 and x equals 4. So 5 and 4 are the values that solve that original equation. And we did this all with U-substitution. So go ahead and take a moment, pause this video, and see if you can find the u value to substitute in for this equation. Okay, trying this out, this again looks like a quadratic equation that we're used to, but in this case, instead of parentheses, we're dealing with an exponent of 4 here and an exponent of 2 here. So why don't we say let u equal x squared? If u is x squared, then we, instead of having x to the 4th, can have u squared, since u squared would be x squared squared, which is x to the 4th. Plus 2 times x squared is now 2 times u. Plus 1 equals 0. Suddenly, this is just a standard quadratic equation. U squared plus 2u plus 1 equals 0, which we can quickly factor into u plus 1 times u plus 1, and now solve by setting each factor equal to 0. Since this is the same factor repeated, we can just say u plus 1 equals 0. And solve for u by subtracting 1 from each side to get u equals negative 1. But remember, we did not want to solve for u at the beginning. We wanted to solve for x. So we substitute u's value back in at this point, now that u is solved for, to get x squared equals negative 1. And if we solve for x, we can take the square root of each side of the equation, which gives us x equals plus or minus, because we took the square root of each side, the square root of negative 1, and the square root of negative 1 is I. So x equals plus or minus I.